Okay, good.
Hello, my name is Jerry Lotto, and I'm relatively new with Mellanox, been there less than a year. I wanted to start out with this slide, but as I look around the room, I realize I don't need to tell this group anything about the history of HPC. The point of this slide is simply to call out 3 transformative events that have occurred. The first, of course, is the symmetric multiprocessor machines gave way to Beowulf architecture clusters. The second, the transition from single-core to multi-core processors, allowing for a greater degree of parallelism than ever before. And then the most recent, which we've talked about, several people have talked about today, is the issue of co-design. The idea that heterogeneous architectures can realize acceleration by dividing up an application and focusing the components or the algorithms on the hardware that's optimized for each component of that algorithm. Now, Mellanox is a networking company, an internet company, and there are 2 different philosophies for networks. In a CPU-centric architecture, the network is a fast pipe, but data needs to be delivered all the way to an endpoint before any processing can occur. What Mellanox is trying to do is to promulgate this idea of a data-centric network. It honors the principles of co-design, actually introducing a new category of coprocessor in the network. It creates the opportunity to analyze data as it moves. We can use something like an MPI all-reduce collective as an example of this. In the CPU-centric situation on the left, you see in the upper left-hand corner where the root process is running, every node participating in this collective needs to deliver its results. There's a bottleneck that's created there. And even if the network latencies and bandwidth are very good performance, the communications fabric latencies tend to go up around 30 to 40 microseconds in situations like that. On the right side, you see a data-centric approach where the network switches actually participate. They recognize the collective, and they can perform inter-collective operations. By doing that and just delivering the result, you can see how the net amount of data that needs to traverse the fabric is reduced. It has a secondary benefit of removing that bottleneck because the end packet is a single result that needs to be delivered to the root process. And all of the processing that that root node would have needed to perform in order to could do the computation involved in the collective has been done already. Now, Mellanox makes end-to-end networking products. You're probably familiar with HCAs and switches. We also have accelerated HCAs with Innova, FPGA equipped, and Bluefield, ARM array equipped adapters. But the technologies that each of these products support and introduce, things like RDMA, Core Direct, et cetera, are the key to the message that I'm trying to deliver. And you see with the Quantum and Switch IB2, we support SHARP. Stands for Shared Hierarchical Aggregation and Reduction Protocol. And SHARP is the method by which we can provide these offloads and do the computation on the fabric.